Hello, dear student, and hope that you are all fine today. This is Isra Saad from Science Team at New Generation Language School. So, first at all, we are going to talk about the Unit 1 periodic motion. So, we'll start with lesson 1, oscillatory motion. So, we'll start with there is two types of motion, which are traditional motion and periodic motion. First, we are going to talk about the periodic motion. It is a motion which is regularly repeated in a equal period of time, and we have two examples of periodic motion, which are number one, oscillatory motion, and number two, wave motion. So, in this lesson, we are going to talk about the oscillatory motion only. First, the definition. It is a periodic motion of the oscillating body around its rest position or around its rest point, where the motion is regularly repeated through equal period of time. So, what is the relation between the velocity and the oscillating body and its kinetic energy? First, the kinetic energy equal half mass times square the velocity. So, the kinetic energy of an oscillating body is directly proportional to first, the mass of the oscillating body, and number two, the square the velocity of the oscillating body. So, the kinetic energy increases when the velocity of oscillating body increases, and vice versa. When the kinetic energy decreases, when the velocity of the oscillating body decreases, and vice versa. Brilliant. First of all, we're going to talk about this example. Which of the following movements represents an oscillatory motion and which not? Then give reason. Number one, stretched string, rotary bee, pendulum, spring, tuning fork, motion of swing. Okay, so the solution is oscillatory motion. We have number one, stretched string, number two, pendulum, number three, spring, number four, tuning fork, and finally, motion of swing. And all these movements are oscillatory motion because it's repeated regularly at equal period of time on the two sides of the rest position. And what about the rotary bee? It is motion considered as a periodic motion only because it's repeated regularly at equal period of time, but it's not an oscillatory motion because it's not repeated on the two sides of its rest position. And now we are going to talk about the application of the concept of oscillatory motion and the motion of the spring. So first we have the rest position and ball above it and ball below it. So first, on the rest position, the motion of the spring is regularly repeated in equal period of time at the two sides of its rest position. And what about the maximum displacement? The velocity of the oscillating body decreases when it goes far from its rest position until it reaches zero at the maximum displacement. And the velocity of the oscillating body very high when it passes its rest position. Look at this motion. It's called simple harmonic motion. Amazing. So, in this simple harmonic motion, the velocity of the oscillating body is inversely proportional to its displacement away from its rest position. So, the velocity of oscillating body increases as it is approached the rest position point A and vice versa. Amazing. And now we're going to talk about the properties of oscillatory motion. So we have four properties. Number one, amplitude. Number two, complete oscillation. Number three, periodic time. And finally, frequency. First of all, we are going to talk about the amplitude. Look at this picture. We have the maximum displacement that the pendulum makes when it oscillates from its rest position A. On the right side at the point C, the displacement AC equals the displacement CA, and in the rest position, the displacement AP equals the displacement AC, and on the left side at point P, the displacement AB equals the displacement PA. So, What is the meaning of amplitude? Amplitude means it is the maximum displacement achieved by a oscillating body when away from its rest position, and the measuring unit of the amplitude is meter. So, what is meant by the amplitude of an oscillating body is 20 centimeter. So, we will put the definition of amplitude. So, this means that the maximum displacement of oscillating body away from its rest position is 20 centimeter or 0.2 meter. And number two, the maximum displacement of oscillating body is 6 centimeters. So we will put the scientific term. So it is, or this means that the amplitude of the oscillating body is 6 centimeter or 0.06 meter. Perfect. So now we're going to talk about the complete oscillation. So when the pendulum move back and forth, then from A to C, then from C to A, and from A to B, then from B to A. And when it begins to repeat it, it moves again from A. It said that it has made a complete oscillation. So complete oscillation means it is a motion of an oscillating body when it passes by a fixed point on its path two successive times in the same direction. Number three and number four, periodic time and frequency. So we will make a comparison between them. So first, definition. Periodic time, it is a time taken by a oscillating body to make one complete oscillation. And about the frequency, it's the number of complete oscillation produced by an oscillating body in 1 second. So after that, we're going to talk about the measuring unit. So the measuring unit of periodic time is second, and the measuring unit of frequency is oscillation per second, or hertz, relative to the German scientist Hertz. And this is about the graph. Perfect. So now we have two questions. What is meant by the periodic time of an oscillating body is 0.2 seconds. This means that the time taken by this oscillating body to make one complete oscillation is 0.2 seconds. And the frequency of an oscillating body is 20 Hz. This means that the number of complete oscillation produced by oscillating body in 1 second is 20 complete oscillations. And finally, what about the laws? First, periodic time equal time in seconds over number of complete oscillation, and frequency equal the number of complete oscillations divided by times in second. Perfect. What is the mean to pi? The time taken by a spring to make 60 complete oscillation in 1 minute. So the periodic time of the spring is 1 times 60 divided by 60, which equals 1 second. And what is meant by the number of complete oscillation made by an oscillating body in 1 second is 60 complete oscillations. This means that the frequency of the oscillating body is 60 divided by 1 times 60, which equals 1 Hertz. Perfect. So remember that the value of the periodic time will be equal to that of the frequency when the number of complete oscillation made by the oscillating body equals to the time taken by seconds. And the scientist had designed the pendulum watch, considering that the pendulum oscillates at constant frequency whatever the amplitude changes. And to remember, Hertz equal 1 times 10 power 3 Hertz, and megahertz is equal 1 times 6 power 1 times 10 power 6 Hertz, and gigahertz equal 1 times 10 power 9 Hertz. And thank you so much. See you later. Goodbye.